This video will cover the topic using the rational zeros theorem to find all zeros of a polynomial, rational zeros. The rational zeros theorem can be stated as follows. Let g of x equal a sub n x to the power of n plus a sub n minus 1 times x to the power of n minus 1, so on and so forth, plus a sub 1 times x plus a sub 0 be a polynomial with integer coefficients and a sub n is not equal to 0. If g of x has a rational zero, then the zero can be written as p over q, where p is a factor of a sub 0 and q is a factor of a sub n.
How do we relate this theorem to the types of problems we'll be given?
Let's say we are given the polynomial g of x equals 10x cubed minus 33x squared plus 8x plus 3. We are given that it has at least one rational zero and asked to find all zeros of the function. To do this, we'll first need to identify a sub 0 and a sub n. A sub n is the leading coefficient, so a sub n equals 10. A sub 0 is the constant term, so a sub 0 equals 3. Using the rational zeros theorem, we know that the only possibilities for rational zeros of g of x are the numbers of the form p over q, where p is a factor of a sub 0 and q is a factor of a sub n. So any rational zero of g of x must have the following form. P over q equals a factor of 3 over a factor of 10.
So we need to find all the factors of 3 and 10, right?
That's right. The possible values of p are the factors of 3, positive and negative 1, and positive and negative 3. The possible values of q are the factors of 10, positive and negative 1, positive and negative 2, positive and negative 5, and positive and negative 10. So the possible values for p over q are listed below. Next, we can check these numbers until we find a zero of g of x. 1 over 1 simplifies to 1. When we substitute 1 in for x, we can see that g of x equals negative 12. This does not equal 0, so it is not a zero of g of x. We can follow this same process until we find a zero of g of x. We can see that 3 is a zero of g of x. And we can use this knowledge to find the remaining zeros of g of x. Based on the factor theorem, there must exist a polynomial q of x that satisfies the following equation. G of x equals x minus 3 times q of x. The x minus 3 comes from our knowledge that 3 is a zero of g of x. How can we find what q of x is?
I think we can divide g of x equals 10x cubed minus 33x squared plus 8x plus 3 by x minus 3 to solve for q of x.
That is correct. We will use division to solve for q of x. If you would like to brush up on your division skills, I would suggest reviewing the topic polynomial long division. The result of this division here is q of x equals 10x squared minus 3x minus 1. We can find the remaining zeros by using the polynomial we found to be q of x.
And we can do this by factoring the polynomial, right?
Yes, we can factor this polynomial into the factors 2x minus 1 and 5x plus 1. If you need a refresher on factoring, I would recommend reviewing the topic factoring polynomials. From here we can solve for x by setting each factor equal to 0 in this way. We already have our first rational zero of 3 from our first factor telling us that x equals 3. We can solve each of the other linear equations in this way. For the first, we will add 1 to both sides, resulting in 2x equals 1. Next, we will divide each side by 2, resulting in x equals 1/2. The second can be solved in a similar way. Subtract 1 from each side, then divide each side by 5. This results in x equals negative 1/5. So the remaining rational zeros for this function are 1/2 and negative 1/5.
And our final answer is 3, 1/2, and negative 1/5.
Great work!
Okay, so when finding all zeros of a polynomial using the rational zeros theorem, the only possibilities for the rational zeros are numbers of the form p divided by q, where p is a factor of the constant term and q is a factor of the leading coefficient. Next, we use the factor theorem and the rational zero we found to find the factors of this function, giving us the remaining zeros we need to answer this problem.
Good summary! You definitely understand this topic.